Hello everyone, and it's been a while that I haven't uploaded any single YouTube video last week, and I do believe also last 2 weeks ago because I have priorities to do, especially when it comes to personal matters. So let's continue this series, the trigonometry series. To be particular, we're going to finish this test, this right triangle trigonometry test, so that after that we can now proceed to the next topic, which I do believe it's about graphing of trigonometric functions. All right, so without further ado, let's now begin. So here we have a first problem. Suppose there is a rectangular garden and its ratio is 4 to 12. What will be the diagonal length of this garden? Now, let's try to visualize a problem first. We have a rectangular garden, right? So let's assume that this is the rectangular garden. Okay. In this way, okay, this is a example of a rectangular shape, but imagine that this is just not a rectangular shape, but it's a garden. Now, according here, the ratio of the rectangular garden is 4 is to 12. So what does that mean? This ratio tells you the measurement of the dimensions of this rectangular garden. So what does it mean when you say measurement of its dimension? Meaning, what would be like the measurement of its vertical side and what would be the measurement of its horizontal side? So in this case, we have 4 is to 12. So 4 and 12 are like the measurement of its respective dimensions. So what does that mean? Meaning the shortest side of the rectangular garden is 4 units long. So here, since we have two pairs of short sides that are parallel to each other, we can say that this is in 4 units long. Then here, the longest side, which is, I do believe, uh, it's uh, it's the horizontal sides. Its measurement is 12 units long. So we have the horizontal sides have a measurement of 12 units long. Now, you see in a rectangle, there's one thing that you need, there are two things you need to know. Each corner of the rectangle has a right angle. So that means we can have a right angle here in each of the corner. And this right angle is, in other words, 90 degrees angle. Okay? So now, another thing that we need to know is that a rectangle shape has a diagonal length. Okay? It's either starting from here, going there. So let me just draw it here, like from here to there, like that. Or it could be from here going here. So from there to there. All right? It's up to you. Now, that is our goal. We will find its diagonal length. So now, we should pick either our diagonal length would be like this, from top left to bottom right, or from bottom left going to top right. For me, I'm just gonna pick this one. All right, this is much better. Well, now, how do we find the diagonal length? To find the diagonal length, imagine that this diagonal length is like it's the that diagonal length is basically the part we're going to slice the rectangular garden into half. So imagine that this being cut into halves and the segment of it is its diagonal length. All right. So let's just say I will remove the top part. So we will have like this as a result, right? We will have like this. All right. Now, if you're going to take a look closely, this is actually a right triangle because a right triangle has a right angle. All right. So in here, for us to find a diagonal length, we can apply Pythagorean theorem. All right. So again, for us to find the diagonal length, we can use Pythagorean theorem. Remember that in a Pythagorean theorem, if we have a given right angle, I like this for example, and then there is a right angle here. So let's just say the side on the top is A, side on the base is B, and the longest side, which is the hypotenuse side, is C. So if we're going to apply Pythagorean theorem, we will have A squared plus B squared is equal to C squared. So that means that the sum of the squares of two legs of the right triangle is equal to the square of its hypotenuse. All right? So we can use this to find the diagonal line. So with that, we can say that our A is 4, our B is 12, and the C, that would be the hypotenuse. In this case, that would be the diagonal line. All right, so we will apply Pythagorean theorem here. So A squared plus B squared is equal to C squared. So our A is 4, so we will square 4 here plus 16 squared. So we will have 16 squared is equal to C squared. All right. So in this case, we're going to look our C because that would be the measurement of our diagonal length. So the 4 squared, that would be 16. 16 squared? What's 16 squared? 16 squared is 256. All right. So we have this one. Now, we're going to add these two numbers together. 256 plus 16. That will give you exactly 272. Now, for us to find the C, or the diagonal length, we will square root both sides. So if we're going to square root 272, our answer here is exactly 4 square root of 17 is equal to C. This can be your final answer. But in reality, when it comes to knowing the measurement of anything, like for example, the measurement of a side, a measurement of the height, we need to get at least its approximated value. All right. So in this case, you see this one, this we cannot exactly know its measurement because it has a radical number. Basically, it has a root number, which is square root of 17. So it's best to approximate it for us to know the measurement. So here we can approximate it at two decimal places or round off to two decimal places. Our answer here would be 16.49 units. All right, that is our answer. Okay, 16.49 units. Okay, so that's the measurement of the diagonal length. All right, it's 16.49 units. Next question. Suppose there are two cars in one place. One is driving due north and the other is driving due west. At an instant, the distance between the two is approximately 2 kilometers, and the total distance traveled by a car whose direction is going north is 1 kilometer. What will be the total distance traveled by a car whose direction is going west at this instant? So let's visualize the scenario first. Okay, so let this be, circle as the car that is driving due north. And we have a red circle, that's a car that's driving due west. So initially, they are in one place, okay? They're like that, in one place. Then, in the next scenario here, the, the blue circle is driving due north. So we can say that from that place, it's actually going here. All right, it's going up, going north. Then the other is going west, which is basically on the left direction. So we can say that it looked like this. All right. So from this starting position, then they go in their own direction. Now, at an instant, the distance between the two is approximately 2 kilometers. So let's just say that at this instant, their distance, their distance between the two is 2 kilometers. And the total distance traveled by a car whose direction is going north is 1 kilometer. So let's just say that this is the starting position. And then at that instant, let's just say that the blue car or the cars driving due north stops right here. It achieves 1 kilometer. All right. Now here, what will be the total distance traveled by a car whose direction is going west at this instant? So at this instant, what would be the distance of this red car from this instant? Yeah, no, from the start until this instant. So from here going there. So here we can apply Pythagorean theorem. Why? Does this look like a triangle? Yes. But is this triangle is a right triangle? The answer is yes. How would I know that this is a right triangle? Because if we have a side that is going in a vertical direction and the other side is going on the horizontal direction, we can say that these two sides are perpendicular. So these two, the vertical and the horizontal, these are perpendicular to each other. All right. And what I mean by perpendicular, it's like you're making a cross, all right? Like this. You're making a cross, just like this. And since they're perpendicular to each other, that means they have a right angle between them. All right. So here we have a right triangle. So with that, we can apply Pythagorean theorem. All right. Remember that our formula of Pythagorean theorem is basically a squared plus b squared is equal to c squared. Now we can say that our A is 1 kilometer, B is the missing side that we're going to look for, and C is the longest side. So that means 2 kilometers is C. So our goal is we're going to find B in this situation. So your A is 1 kilometers squared plus your B, the one that we're looking for, is equal to C squared, which is 2 kilometers squared. So 1 kilometer squared is just basically 1 kilometer squared. All right, nothing changes. The only changes here is the units. If you're going to put an exponent, make sure that the units should be included. Okay, so here we have the square of 2 kilometers. So this is 4 kilometers squared. Now, let's find our B. So first, we will transpose 1 kilometers to the right side. So we will have B squared is equal to 4 kilometers squared minus 1 kilometer squared. So here, we will have exactly 3 kilometers squared. Now, for us to find our B, we will square root both sides. So we will have B is equal to square root of 3 kilometers. So this is already a valid answer. But again, in reality, we want to know at least the approximated measurement because in here, when we have a radical term, or basically a term that has a root, just like here, square root of 3, we can actually know what is the value here. At least it's approximation because we can't exactly measure what is square root of 3. So we must round it off at least 2 decimal places. So if you're going to round it off into 2 decimal places, square root of 3 is 1.73. Okay, 1.73 kilometers. And yeah, that's it. That is our B, which is the total distance traveled by a car whose direction is going west. So this is 1.70, so yeah, 1.73 kilometers. Okay, so we're done with the second question. Now let's proceed to the next question. A man is approaching to a 5 kilometer tower. At an instant, the length of the distance between the tower and him is 2.57 kilometers. What is the angle of elevation from the tip of the feet of the man to the tip of the tower? So in this problem, we're going to visualize a man approaching to the 5 kilometer tower. So let's just say this is a man, all right? Think of it that this is a man, okay? This is a man. Or you know what? Let's just do a stick man figure. I think that's much better, right? So like this. And it's going to 5 kilometer tower. So assume that this is a tower, 5 kilometers long. Now, let's just say at an instant, let's just say he's here, okay, at this point. Okay, let's just say he's here. So at that instant, let's just say in this moment, assuming speaking, the distance between the tower and him is 2.57 kilometers. So from this point, from here, this is 2.57 kilometers. Now, what we're going to do now is we're going to find the angle of elevation from the tip of the feet of the man to the tip of the tower. What is angle of elevation? So let's have a recall that if you're going to know angle of elevation is basically an angle formed from the horizontal line of sight. So for example, from this horizontal line, we're going to form an angle upward. So we will go from here to there. So assume that we have an angle here. All right. Then here we will have its terminal side. All right. So with that, if an angle is formed above the horizontal line, we can say that this is an angle of elevation. So here, angle of elevation from the tip of the feet of the man to the tip of the tower, it means that from this horizontal line, from here going up, right? From here going up. So starting from the tip of the feet of the man or feet of the man, wait, let me fix this. From tip of the tip from the feet of the man, then going to the tip of the tower. All right. So yes, we're going to find the angle of elevation in this tower. Now the question is how? All right. Now that we know visually and graphically speaking where angle of elevation is, which is basically here. Which is basically here. Now the question is how? How are we going to do it? Now we're going to recall a trigonometric ratio. Right? There are six trigonometric ratio, and we're going to at least pick one of them. Right? At least pick one of them. Now the question is which one? Right? Which one? Now that depends on the sides you have. So we have 2.57 kilometers. We have 5 kilometers. So in a right triangle, okay, in a right triangle, let's just say we have an angle here. If we have an angle here, the hypotenuse is the longest side, which is this one, the diagonal side. Here on the bottom, the what equals one, the base. Since the base is next to the angle, we say it as an adjacent. While the vertical side, since it's not adjacent, or rather it's not beside to the angle compared to the base, that's the opposite. So now, if we're going to refer our angle, which means that we're going to refer to the angle of elevation, that means that it's the hypotenuse, this is the opposite, and this is the adjacent, because it's basically closer to or beside to the angle A, right? So now, what we're going to do here is we're going to find a trigonometric ratio where it has an opposite and adjacent. So there are two. First is we have tangent theta. Tangent theta is equal to opposite all over adjacent. So that's one. And the other is its reciprocal, which is cotangent theta, which is adjacent all over the opposite. Now, which one? The question is it's up to you, right? Because both of them have opposite and adjacent given, so it's clearly up to you. So let's try to use both of them. Let's use this one, tangent theta. So we have tangent theta. Wait, let me write it here. Tangent theta is equal to opposite all over adjacent. So here, our opposite is once again 5 kilometers all over adjacent, which is 2.57 kilometers. All right. We will cancel out the unit. So cancel, cancel. So what's left is we will have tangent theta is equal to 5 all over 2.57. Now here, we're going to find this angle, right? Because this angle is our angle of elevation, all right? So how are we going to find the angle? So here, we're going to apply inverse trigonometric function. So to be particular, we will use inverse tangent function because we have a tangent function here. And for us to find the angle, we can just simply use inverse tangent function on both sides. So we will have inverse tangent of tangent theta is equal to inverse tangent of 5 all over 2.57. Now here, we have inverse tangent of tangent theta. So recall that inverse tangent of tangent theta or tangent of inverse tangent theta is just the same as theta, you know. So inverse tangent of tangent theta is just the same as theta, or tangent of inverse tangent theta is just theta. Basically, if you have inverse tangent, then tangent, this would be cancelled out. You will have theta. And likewise, in this case, tangent and inverse tangent, they will be cancelled out. What's left is theta. So cancel out, you will have theta. And yeah, theta is equal to inverse tangent of 5 all over 2.57. So we can use our calculator to find a value, at least by approximation. Inverse tangent of 5 all over 2.57. So this is at two decimal places. This is 62.80 degrees. Okay, 62.80 degrees. And that is our answer. Okay. Now, what happens if you would rather use cotangent theta? All right. So let me just erase this one. So what happens if you're going to use cotangent theta? Well, it's the same. Okay. First, you would substitute the adjacent and opposite side. So we have 5 kilometers all over 2.57 kilometers. Right? Then the kilometers are canceled out. So you will just simply have 5 all over 2.57. Okay. So with that, we will use inverse trigonometric function. So here we will have cotangent theta, so we will use its inverse on both sides. So we will have inverse of cotangent theta is equal to inverse of cotangent inverse cotangent of 5 all over 2.57. And again, just like here, inverse tangent of tangent theta or tangent of inverse tangent theta is theta. So just like here, inverse cotangent and cotangent are cancelled. What's left is we have theta is equal to inverse cotangent of 5 all over 2.57. Now here's the flaw of this. Usually our calculator, scientific calculators to be particular, they don't have they don't have a what do you call this one? A button for cotangent, especially to its inverse. So that's a problem. So what are we going to do in this case? So here you're going to use its equivalent identity. Basically, if we have inverse tangent of adjacent all over opposite. Oh yeah, by the way, guys, forgive me. Forgive me, guys. Sorry. I was wrong. Wait, guys, sorry. I was wrong. Forgive me. It's actually 2.57 all over 5. Okay, I'm sorry because the adjacent is 2.57 and opposite is 5. Forgive me. Sorry, guys. I made a mistake. All right. Going back. Okay, we have 2.57 all over 5. Okay, that's it. All right, let me just rewrite them. Okay. So yes, we have this one, right? So here, we can use its equivalent, which is arc tangent of 1 all over, what's that again? Adjacent all over opposite. So that means, instead of using inverse cotangent of 2.57 all over 5, we can just use inverse tangent of 1 all over adjacent all over opposite, which is 2.57 all over 5. And our answer here is still the same, which is 62.80 degrees. Okay, that's it. right? That is our answer for this problem. Okay, this is our answer for this problem, right? Let's solve two more problems. We have this one. Imagine there is a person at the balcony of the building enjoying the view. Suddenly, he sees his friend jogging outside, so he calls him out to have a short conversation. At this moment, the person is 3.91 meters away from his friend. What will be the angle of depression from the person to his friend when the horizontal distance between them is 1.36 meters? Okay, so the person is at the balcony. So assume that we have a balcony here, right? Just imagine it, right? This is the person, right? This is the person, and then he sees a friend, right? So at this moment, okay, let's just say that our friend is here. Our friend is here. The distance between them is 3.91 meters away from his friend. So from him going to him, this is 3.91 meters. Then uh, the goal here is we're going to find the angle of depression when the horizontal distance between them is 1.36 meters. So let's just say that here the horizontal distance is 1.36 meters. Now here, what will be the horizontal distance between them? It's the same as the horizontal distance or horizontal component of this diagonal line. Okay, like if you have 1.36 meters here, we can also have 1.36 meters as a horizontal component of this diagonal line. All right, so that means this is just the same as what as their horizontal distance between them. So we can have 1.36 meters as the horizontal component of this diagonal line. Now, here's the thing. We can actually form a right triangle here. We have the diagonal line, the base, and then let's just say that we can have its vertical, what do you call this one? Vertical component, which is this one. All right. So with that, we can rewrite it this way. Okay, we can rewrite it that way. So we have 3.91 meters, 1.36 meters, and its vertical side, which is the missing. Okay. So now, since yeah, we have a vertical side and horizontal side, so the corner of them between them is a right angle. Okay, so we're going to find angle of depression. So what is angle of depression? Remember that in the horizontal line of sight, I mean, in a given horizontal line of sight, if we have an angle forming above the horizontal line of sight, which is from here going up, okay, you form an angle. Okay, so this one is your angle of elevation. But if it's below the horizontal line, like from this going there, so this is your angle of depression. Now, here's the problem. Where would you form angle of depression in this case? Right, where would you draw it? Okay. Let me just erase the dimensions or the measurements rather, right? So that it wouldn't be messy, like it's not complicated to look at. So where would we draw it? So here, actually, we can imagine a what do you call this one? We can imagine drawing its parallel sides, you know, like right. We have a horizontal line, which is this one, right? This one. Let's just say we can draw another horizontal line starting from this position, right? So we have this one. We have this one. We can do that. And then its vertical side, which is this one, we can draw its parallel side starting from this position. So here going there. Okay, so what of it? All right, what of it then? In here, you see we are at the position of this person. And remember, again, angle of depression is an angle below the horizontal line. So with that, we can start forming an angle from this position going this position. So this is our angle of depression. All right. So in this case, guys, when in doubt, like you have already a right triangle, but you do not know where to draw angle of depression because it looks like this, okay? And you know that angle of depression it will form below the horizontal line. So what we're going to do is just simply draw two sides, all right? Which is one a parallel side of its horizontal, starting from this tip here. So we have this one and we have this one. And at the same time, here we will have its vertical parallel side for this one from this position from here, then going there. And here we can now form an angle of depression from this going here. So this is your angle of depression. So with that, I think I'm gonna erase this one. All right, let me just get this part only, like this part. All right, so let me just erase this one. Okay, there we go. Now, the given measurements. So here we will have 1.36 meters and 3.91 meters. Remember that in a parallel side, if this is 136, then its parallel is also 1.36. Okay? Then the diagonal line, it's 3.91 meters, so it doesn't change. Okay, now here's what we're going to do. Now we're going to find its angle of depression. The question is how? So just the same as in the previous problem, we're going to find at least one trigonometric ratio. The question is which one? Now, first and foremost, I want you to rotate this one, rotate this one counterclockwise, where this one acts as a base. The red side acts as a base. So what happens here is we will have like this, like that, like that. Oh, wait, no, no, no. Wait, like that, and that's it. Right, that's it. So yeah, here we have angle of pression 3.91 meters, 1.36 meters. That's it. Now we can label the sides or we can label the parts of this right triangle, right? So here, 1.36 meters, since it's next to the angle, so this is your adjacent. The hypotenuse, that would be 3.91. It's obvious. And this one is just the opposite because it's not adjacent to the angle of depression. Now, we're going to pick a trigonometric ratio that has a given adjacent and hypotenuse. And there are two of them. And those are cosine theta. So cosine theta has adjacent all over hypotenuse. And secant theta, it's reciprocal of cosine theta, which is hypotenuse all over adjacent. So again, it's up to you which one would you pick. But for the sake of this video, I'm just gonna pick cosine theta only. All right, or we can do both. All right. So let's try both. I think that would be much better. So cosine theta is equal to adjacent all over hypotenuse. So here we can substitute. The theta we're looking for is the angle of depression. Or let's just represent this as angle of depression. All right. So here we're going to we're going to substitute. So our adjacent is 1.36 meters all over your hypotenuse, which is 3.91 meters. So we cancel out the meters. What's left is we have 136 all over 3.91. And since we have cosine given, and we're going to find the angle of depression, which is this one, we're going to use inverse cosine. All right, just like what we did earlier. In finding of angle, we're going to use inverse trigonometric function, and that depends on the trigonometric function you have. So you have cosine theta, so we will use inverse cosine theta on both sides. So we will have inverse cosine theta is equal to inverse cosine of cosine theta is equal to inverse cosine of 1.36 all over 3.91. Okay. So here we have inverse cosine of cosine. So we can cancel this one. So we will have theta is equal to inverse cosine of 1.36 all over 3.91. So here, inverse cosine of 1.36 all over 3.91, approximately at two decimal places, you will get 69.65 degrees. 69.65 degrees. And that is the answer. All right. Now, what if we use secant theta? All right. Secant theta as our chosen trigonometric ratio. So yes, we can use that, right? But first, let me just quickly substitute this one. So secant theta is equal to your hypotenuse, which is 3.91 meters, all over your adjacent, which is 1.36 meters. Right? The meters are canceled out, so we can just have 3.91 all over 1.36. And since we use secant theta and we're looking for the angle, so we're going to use inverse trigonometric function for us to find the angle. So in this case, we're going to use inverse secant on both sides. So inverse secant of secant theta is equal to inverse secant of 3.91 all over 1.36. That's it. Here, just like what we did earlier, if we have inverse secant of secant, like inverse cosine of cosine, like inverse tangent of tangent, we can just simply cancel them. So we will have theta here is equal to arc secant of 3.91 all over 1.36. Now here, just like for the cotangent, secant to secant and cotangent itself, they are not commonly present in a scientific calculator, right? Like in a scientific calculator, it's only sine, cosine, and tangent. Only the three trigonometric functions are given, and so it's inverse function. So that means we do not know the uh, what goes on. So that means what if we pick this ratio, but we do not have secant, cosecant, and cotangent in our calculator? So here we're going to use its equivalent. Okay, so inverse secant of hypotenuse all over adjacent is just the same as inverse cosine of 1 all over hypotenuse all over adjacent. Okay, so that means we can get the angle here. Instead of using inverse secant, we can use inverse cosine of 1 all over hypotenuse all over adjacent. So our hypotenuse is once again 3.921 all over 1.36. And here, if you're going to use your calculator, the answer is still the same, 69.65 degrees. Okay? 69.65 degrees. All right? And that's it. That is our problem for today. Supposedly, it should be only one, but because of the time given there, I think it's better to finish this problem or finish this test right now. Right? Let's just stop right here. And I think let's proceed now to the next topic. Okay, so that will be all, guys. So thank you for watching this video and see you soon.